Hi everyone, welcome to the second half of our completing the square video. Now, in that previous video, we were looking at a couple of techniques for visually showing what completing a square looks like. And we introduced this idea of taking this portion here and looking at the coefficient in front of x. And what we did to complete the square involved us halving that number and then adding it on at the end. Now, some of you may have noticed that in doing that, right at the start, we kind of violated a purely mathematical thing. So we were just adding numbers out of the blue and pretending it was okay. Now, since that was a video to just show you the visual idea of what that is, something we did there was fundamentally incorrect. And we're going to talk about that a lot more in detail in this video and look at what we want to do to actually factorize by completing the square and do this in a way that we're not violating any mathematical rules. Because, for example, in the previous video, we would do something like this. We would just take this and we'd add 1 to it, because this was the idea of getting my x squared and slicing my 2x in half. So I would get x by 1, 1 by x here. And then we just looked at what was this extra box. And then we would end up adding this number. But I can't just add a number out of nowhere, because this entire expression is a different number than, it's a different expression entirely, because something new has been added. So we're going to see how to navigate this in an actual question. So using our completing the square method, we figured out that in order to complete this square, now let's leave this plus 8 here, like we had at the start of the question. We noticed that to make this blue underlined section x squared plus 2x into a perfect square, we needed to add some area which was a unit of 1 by a unit of 1. So we would get 1 squared here, which is just 1. So in order to give us a perfect square, we have to plus 1 here. Because now this entire expression I can factorize into a perfect square based on this idea that we looked at down the bottom here, which we talked about at length in the previous video. But what I want to do is I don't want to fundamentally change my expression x squared plus 2x plus 8. These two, top and bottom, are not the same. So we require a little bit of mathematical gymnastics, a little bit of manipulation of these terms. Now, to make the top expression equivalent to the bottom one, as currently these are not the same, I'm adding 1 to this expression at the top. So I'm going to subtract 1 as well, because this thing here now just gives the effect of, because 1 minus 1 is just 0, so I get x squared plus 2x plus 0 plus 8, which is the same as x squared plus 2x plus 8. Now, what I'm going to do is something kind of weird to some of you, but we're going to look at what this is essentially the effect of doing. I want to separate this portion here, my perfect square, from my other values, my constants. So I have my constants here, my regular integers, and I have this portion here is my perfect square. Now this perfect square, we can factorize this using PSF. We have a product of 1 sum of 2. So these factors must be two numbers that add to give me 2, multiply to give me 1, and that's just going to be 1 and 1, which gives me x plus 1 times x plus 1, which in other words is like saying x plus 1 all squared. So this thing here is going to become a factorized perfect square, also known as x plus 1 all squared. So let's write that instead here. So my perfect square now becomes x plus 1 all squared, and to that I'm adding, from that I have to subtract 1 and add 8. So I'm going minus 1 plus 8. And now minus 1 plus 8, that is the same as just writing 7, because I know how to work with whole numbers. I can just add these. Negative 1 plus 8 gives me 7. So I'm going to get, in my final factorized form, x plus 1 squared plus 7. So now this is it factorized, but without violating anything mathematically. Because when we looked at just the section of completing the square in the last video, we were just adding these numbers out of nowhere. But now we have to account for those when we have this extra term here. So we need to, because we're adding a 1 out of nowhere, we need to compensate for that to subtract 1, to give me the effect of something that is my original expression, x squared plus 2x plus 8, but just written in a different way so that I can complete the square. Okay, let's look at another example here. I have x squared minus 8x minus 3. So once again, I'm going to move through this a little quicker now because we should have the idea from the first example and the last video. My coefficient of x, my b in this case, we want to halve that and then square that, and then add the square of half of negative 8 to my expression in order to make a perfect square. So I'm going to get x squared minus 8x plus minus 8 over 2, so half of this coefficient, minus 3. Okay, but as we said, we can't just pull this out of nowhere. So we're going to do some kind of compensation here. So negative 8 on 2 gives me negative 4. All squared gives me positive 16. So in place of this, I'm going to write a positive 16. And let's shift everything across here so we have more space. And whoops. Like we said before, I've violated something mathematically by just adding a constant out of nowhere. This is no longer the same as my initial expression. This is something totally different. So I can't do this. But I can fix this by, since I've added 16, I want to add or subtract another number that's going to give me the effect of 0 in these terms here. So I retain my original expression. So because I've added 16 here, I can subtract 16 in order to consolidate this, in order to balance this out again. Because this thing here now, 16 minus 16, this is the effect of doing 0. So I have x squared minus 8x plus 0 minus 3, which is the same as this guy up the top. Okay, and now the very last thing we want to do is we want to isolate my perfect square. This here is a perfect square. So we want to factorize that and then work with my constants separately. I'm going to get rid of this 0 here because I think you guys have the idea by now. But we want to treat these like their own separate things in order to factorize. Now this thing here we can factorize using PSF. And remember, because of this idea of completing the square, these always end up really easy to factorize because it will always factorize to a perfect square. Now let's just confirm that. I want a product of 16, a sum of -8. Two numbers that multiply to give me 16, add to give me -8 is going to be -4 and -4. So once again, these two here are exactly the same, and they always will be because that's a function of completing the square. That's essentially what we're doing. We're always going to get a perfect square here. So we have x minus 4, or right off the bat, I can just go x minus 4 all squared. Okay. So we're almost done here. Now I can write in for my perfect square, x minus 4 all squared, and I have minus 16 minus 3. And instead of minus 16 minus 3, I can write this as x minus 4 squared minus 19. So this is a pretty nice factorization. Now we can take this a step further in some cases. It depends how fussy your teachers are, but let's think about this -19. We can also write -19 as, well, let's leave my x minus 4 all squared. I can write 19 as the square root of 19 all squared. Because remember, a square root and a power of 2 are going to cancel each other out to just give me minus 19. And here, what we have is a difference of 2 squares, which we know how to factorize. It's just going to be both the square roots of both of these terms, this and this. And in my brackets, when I factorize, one of those is going to be positive, one of those is going to be negative. So this is like saying x minus 4 minus root 19. And then we have x minus 4, the first term there, and the sign is going to change, plus root 19. So this is now the fully factorized form. But sometimes you may not need it exactly in this form. We're going to talk about this a little bit later. But we can either write this like this using the difference of 2 squares, or we can also just leave it in this particular form. This is still good. These two ideas are communicating the same thing. But because of this minus, we can do a little bit of mathematical manipulation to make this a difference of 2 squares. Okay, let's try one more question. And then by the end of this one, we should get the hang of this. Now, when we want to factorize by completing the square, we want to consider this term. We have positive 3. So I want to halve that and square that and add it. So I have, x squared plus 3x plus 3 on 2 all squared. Apologies for the noises outside. Now, 3 over 2 squared, I can just write that as 9 over 4. And I have my plus half here. Now remember, I want to subtract this value that I've added, because I can't just add this out of thin air. So what does this give me? Well, this is going to condense down to, now let's actually just leave this guy as 3 over 2. Okay. Now, we want to factorize this using PSF, and it's a bit weird because we've got fractions, But we can still do something like this. We want two numbers that multiply to give me 3 on 2 and add to give me 3. Oops, sorry, 3 on 2 squared. So we want them to multiply to give me 9 over 4 and add to give me 3. And those two are going to be, it's going to be a perfect square. So you can check this if you'd like, but we're going to get 3 on 2 and 3 on 2. Remember, when we looked at all of these ones, it always ended up being whatever the thing was that was getting squared as my other term. So if we look up here, I had 16, so I had the square root of 16, or 4 squared, or negative 4 squared. That became my other term. Now, just checking these, multiplying 3 on 2 by 3 on 2, I'm going to get the numerators multiplying to give me 9, the denominators multiplying to give me 4, and adding these together, that's going to give me 6 on 2, which equals to 3. So it also addresses the sum part as well. So I'm going to get x plus 3 on 2 outside of x plus 3 on 2. Or in other words, x plus 3 on 2 all squared. Okay, now I'm going to wind up with x plus 3 on 2 all squared minus 9 on 4 plus 1/2. And now doing this, these two, I have once again my perfect square, and I have my constants here. Okay, so my perfect square stays the same. And then this gives me negative 7 on 4. And honestly, we'll leave this one just as is. We don't have to worry about these crazy factorizations. You can do these in your own time as well. Actually, let's just do it because we might as well. Because this is a difference of 2 squares, we can mess around with this a little bit. So this is like saying x plus 3 on 2 all squared minus, this is like saying root 7 on 4 all squared. Because once again, the square root here and my power of 2 are going to cancel out to give me 7 over 4. So we can do a difference of 2 squares because we have 2 squares and a difference. So it's in the name. So we can just take the square root of these, and then we have minus root 7 on 4 outside of x plus 3 on 2 plus root 7 on 4. But that is how we can do a bit of mathematical manipulation in order to work with factorizing via completing the square. Because remember, we can't just pull out these random numbers as we choose. We have to give the effect of, when we put these extra terms, them still adding up or subtracting to give 0. So that way our initial expression is maintained. So we are always accounting for this by doing this extra subtraction here. If we add another number, we have to subtract that same number. So I get the same expression, just written differently. This is where the manipulation comes in. And we did this again up here. It's always going to give me 0. What we add, we have to also subtract to preserve my original expression. But that brings us to the end of the video. Thank you so much for watching, and I'll see you in the next one.